Welcome everybody back. Mr. Clark here. We're going over the law of sine and the law of cosine. Well, more importantly, we're talking about the ratios associated with them, though we will use them to find a missing side length, and we'll go ahead and use the inverse or arc sine and cosine to find missing angle values. So before we do that, we're just going to review a little bit about how the tangent ratio worked in our last lesson, and then we'll get in. So let's go ahead and get started. So again, as we talk about the tangent ratio, tangent of any value is equal to its opposite side over its adjacent side. Again, that is the unique angle tied to our information. So what I mean by that is if it's a ratio of 4 over 5 or 0.8, then we know that there's a specific angle tied to that piece. So that's what we're talking about. We're going to call this A. You know what? Actually, let's bring this down just a little bit. Gives a little more space here. So when we have that set up, we are going to make sure it's a right angle. Call this A, B, and C. We are going to be referencing two angles primarily here, A, B, and C. And again, tangent, if we were to say that this was, we'll say this is A, B, and C, tangent, our opposite side of tangent for A, let's reference that, would be opposite B over C. And tangent for angle B would be its opposite, C over B. Notice again, these are reciprocals. That means they are flipped. So there's our brief review. We're going to deal with the same thing when it comes to sine and cosine. So let's do that. Let's go ahead and reduce a little bit of what we've got up here. We don't need the tangent piece. We can still use everything else. All right. So we're going to deal with sine. Sine of angle A. And we'll go ahead and deal with sine of angle B. Actually, you know what? Yeah, sine of angle B. We'll just start there. So sine of angle A, in our example, would be our opposite side over its hypotenuse, this triangle's hypotenuse. So again, from A, sine, our opposite is lowercase b over hypotenuse A. The same setup here for sine of B. Notice we're just looking a different direction here. Sine of B is equal to opposite over hypotenuse. So sine of B is going to be equal to its opposite, which is C over A. The beautiful thing is there's not a whole lot that changes here when you talk about cosine. So let's do cosine of A. Cosine of angle A is equal to adjacent over hypotenuse. Again, same setup. Its adjacent side, though, is the side that connects to this point A, this side right here. So cosine of angle A, its adjacent side is going to be C, and its hypotenuse, again, still A. Notice the cosine of A and the sine of B are the same thing when it comes to the ratios. And then we have our cosine of B. Again, we're just referencing over here. Cosine of B is still going to be the opposite, or sorry, the adjacent over hypotenuse, but it's got a different adjacent side. Cosine of B, its adjacent side is B over hypotenuse A. Again, this is very similar to this. We're just looking at different angles. You don't have to use both of these. You can use just one. If you have information for one side and one angle, you should in theory be able to solve the whole triangle based on one of the three trig functions that we've discussed here today. But let's go into some examples. So we're going to deal with sine. We're going to say sine of x here is is equal to its opposite over its hypotenuse. So in our case, sine of x is equal to 15. That's the opposite side. And our hypotenuse is 25. In our calculator, we would do 15 divided by 25. Again, you can reduce this down if you want to in your head. I get 0.6. Just as a refresher, the inverse sine of the sine of x is equal to the inverse sine of 0.6. Remember, when you do something to one side of an equation with an equal sign, we have to do the same to both. We've done the same to both. These cancel each other out, basically. And our x is equal to the inverse sine of 0.6. Our calculator can do that pretty easily. And we're going to go ahead and get an angle measure of. Make sure, again, your calculator says degrees up here. If it says RAD, it's radians, you need to switch that. It's a setting in the calculator. Every calculator is different. I won't discuss how, but that needs to be done. We have 36.86 or 36.9 approximately degrees. We could then just go and say 90 minus 36.9 equals and find the measure of angle Y. However, we're not going to, because this is not a practice of how we can subtract from 90. Let's go ahead and do the other side. Sine of Y is still going to be the same thing, opposite over hypotenuse. In our case, the sine of Y is equal to our opposite side. And you know what? Let's use a different color for that, just to keep it easier to follow. Sine of Y, this here, is equal to opposite over hypotenuse. So the sine of Y is equal to its opposite, which is 20. Same hypotenuse, 25. Hopefully you can already see what 20 divided by 25 is, but if you need to calculate it, that's okay, 0.8. Again, when we set this up in a trig, we can go 0.8, and we can solve for an angle of, we said 53.1 approximately. Notice if you add that to our 36.888699, or rounding, we get an even 90. They are complementary angles. They need to add to 90. We're good to go. You'll mostly be using the math to solve for a missing side. We'll use an example here in a second. In fact, actually, let's do that now. If I'm given a sine of 30 degrees is equal to an opposite side of 5 and hypotenuse of we don't know, we're going to go ahead and solve for that. I multiply both sides by x. That's just to get rid of the fraction. Divide both sides by sine of 30 to get x by itself. X is equal to 5 divided by sine of 30. We could do that pretty quickly by taking 5 divided by sine of 30 and then calculate it out. It gives us a missing side length of 10. That's an example you'll see in your homework. So with that said, let's go ahead and do the cosine version. I'll leave that other problem there for you to do. The only difference in this problem is we are not given this. We don't know what this is. But because we know math uses previous knowledge, we do know a squared plus c squared, a squared plus b squared, equals c squared. That's the Pythagorean theorem. And we aren't given the c squared. The only other variation might be c squared minus a squared equals b squared, or c squared minus b squared equals a squared, right? We're not doing those ones, thankfully. We're just dealing with finding c. So we have 9 squared plus 12 squared equals c squared. 9 times 9 is 81. 12 times 12 is 144. And when you combine those, we get 225 equals c squared. the square root of 225, and c squared gives us 15 equals c. Technically it would be plus or minus, but we're dealing with this length here. It is a measurement of distance, so we are not going to use the minus. Now we have what we need. We can go ahead and calculate out our angles. We have cosine of r. Cosine of r is equal to its adjacent over hypotenuse. So cosine of r is equal to its adjacent, which, again, talking about cosine, adjacent, if we're talking about an angle, it's the side that connects it. Notice that this side here does not connect or touch the vertex of r. It doesn't intersect it at all. Cosine of r is going to be adjacent over hypotenuse. Again, you don't need to calculate most of these numbers, but that same setup here, we have 0.6, which we can plug into our calculator in the inverse trig function for cosine, 0.6. And when we calculate that, we should get an angle of 53.13 or 53.1. Again, these are approximate numbers. That's okay. If we're just solving for the ratio, we would just have 9 over 15 or 0.6, and that would be fine. Again, given an angle measure, if we're told a cosine angle was 53.1 equals, and we were given the hypotenuse, 15, but we weren't given this side here, we could say 15 times both sides. That cancels out the fraction. Cosine of 53.1 equals x. And we can type it into our calculator. And we get 9.0063, or roughly 9, and notice that's the answer here. So, as we can see, we've now solved for a missing side. We've used the inverse, or arc, trig functions to find for a missing angle if that was the case. And we can calculate all these through to get what information we need. So as a review, let's go ahead and create just a blank workspace here. And then we'll go into a problem that we can deal with. So, either cosine, which is our adjacent over hypotenuse, or sine, which is equal to our opposite over hypotenuse. When we talk about these pieces here, they are ratios. You would have some angle in here. We're calling Greek letter theta here, but we can use any letter in there to reference an angle like S or R or any of those. And we're given information to solve either for this, if we're given everything here, or if we're given our angle, let's say we're given this here, we can solve for one of these sides here, either opposite or hypotenuse. The only difference in this problem here that we're looking at, this right here, is that we have a missing side, but we can use the Pythagorean theorem to get that. So in this example, 16 squared plus 30 squared equals c squared. 16 to the power of 2 plus 30 to the power of 2. Square root that. And we have 34. That gives us that piece. Now, we can go and plug all that information in and solve for either the missing angles or the side lengths. In this case, I'm looking at ratios, so we're going to just say the missing ratio, or what the ratios are. So if I say cosine of S, or cosine of R, we can say the cosine of S is adjacent over now 34. Cosine of R equals its adjacent over the hypotenuse. That's fine. That's dandy. We can do that. We can then use the inverse to solve for the angles if we want. Or if we have a ratio, like 16 over 34, or I should say 16 over x, and we have a measure angle of cosine r, let's say it's 25 degrees, then we can solve for the missing piece by getting x by itself, using our calculator to determine the value for x. The other variation to this might be something like this, where our x is in the numerator. This one's a simple setup as well, and we can do that. That is everything that we will be covering in this lesson. Let's go into the example. Might as well get that going. A couple of things we're going to talk about. The line here is the angle of depression. We want to think about depression right now. We're all stuck inside of this wonderful weather, so let's say declination. Why not? We would on the other side have the angle of inclination. An incline and a decline. That's really all that's happening here. So if I was down here looking up at this skier on the top of the hill, from a parallel line perspective, this opening is my angle of inclination. For the skier looking down here to me at the base is the angle of depression. The value is given at 21 degrees. We're asked to find this length here. So again, if we're talking about opposite over hypotenuse, we should remember that that is sine. So sine of 21 degrees equals opposite over hypotenuse. We don't know. That's okay. We can do some simple math to get there. Multiply both sides by x. That gives us x times the sine of 21 degrees equals 1200. We don't want x to have anything there. Again, we will divide both sides by the sine of 21. Remember this, if you have 5x equals 10 dividing by 5, right? That's the basic principle happening here. This whole thing is one thing. So when we divide by, we're not dividing by part. We're not dividing by this section or this section. We want the whole. So we are actually dividing by this whole piece of information. That cancels. X equals 1200 divided by the sine of 21 degrees. We can use our calculator to determine this. And we get 3348.51. We'll just say 3,348. 49, we'll say that. Approximately 3,349 meters. Now remember, going into this, we could have, if we were given the information as what's the angle, I want to know what angle I'm looking down at, maybe the angle or the grade that I'm going to be looking at going down this big hill. I want to know, hey, is this going to be too crazy for me? I can actually do the same setup and we would be given different information. So let's say we weren't given the angle. So we're saying sine of something is equal to our opposite, 1200 meters. And we're told that it's 3,349 meters. We can take the arc sine of that whole mess, and then we can solve for x. So let's just check and make sure our math is right there. It should work the other way. The inverse sine or arc sine of 1200 divided by 3349 should give us 20.9968 or roughly 21 degrees, and it does. Again, we can look at the math and say we can solve for a missing side, we can solve for the angle, we can look at the ratios. That is everything that you will do in this lesson. I'm sorry this video went just a little bit longer, but I just want to make sure that we've got a good understanding. we've put more emphasis onto this piece with the arc, inverse sine, all of this stuff right here, because it's going to come up and we might as well get the practice in now, and we might as well talk about it now. So with that, if you have questions, please ask. I'd be more than happy to answer anything related to the lesson. Just make sure you're trying to practice the work, go through the stuff, and then if you get stumped, that's when you want to ask, so you know what you're asking. The question, I don't get it, isn't really a question, it's a statement. Make sure you are putting the effort in, and then generally ask questions when you're ready. Again, let me know what I can help you out with. Until next time, see you later.